Hello everyone, welcome back to the physics class. On that day we were discussing about electric dipole. What is an electric dipole? Suppose we take two charges minus q and another charge positive q. So if these charges are separated by a very small distance which is called 2a, it is very small, then this whole arrangement is called an electric dipole. The midpoint of this line joining minus q and positive q is called center of this dipole, and it is a distance away from this negative charge and a distance away from positive charge. So this is an electric dipole. Now important thing about this electric dipole, as you saw that direction of electric field is always from positive to negative, but the direction of a dipole is always from negative to positive. So the direction of this dipole is always from negative to positive. So this is the direction of this dipole. Here it is this. By convention, the direction from minus q to q is said to be the direction of this dipole. This is from minus to positive q. Now on that day we saw that if there is a point P, the total charge on this dipole is minus q plus q, hence 0. But if we try to measure electric field at this point P, there is a point P which is some distance from here and some distance from here, and we are trying to measure this electric field on this point P. So we saw that this electric field is not 0. There must be some electric field. The reason was that there is a small difference in these charges. Difference means difference in terms of distance. These are not exactly at the same point. If there would be one positive, one negative charge at the same distance, at the same place, so at any external point P, the electric field E would be 0. E would be 0. But since there is no coincidence between these two charges, that means they are not at the same place, so there would be some electric field at P. There must be. Let us take another case where P is very far. P is very far from this. So here it is P. This is charge 1, this is charge 2, negative charge, this is positive charge, and the distance is quite large. This distance is quite large. So the dipole distance 2a and this distance r. So r is very large in comparison to 2a. In that case we can say the electric field E is approximately 0, because the contribution due to negative and positive charge cancel out, but at large distances. So on that day we saw that we can calculate the electric field due to dipole, and we arrived to this conclusion that E is equal to non-zero for near to dipole, and E is nearly equal to 0 where the distance is quite high. R is greater than in comparison to 2a. But even at lower distances, the electric field due to dipole thereof falls off faster than 1 by r square. For a single charges, you saw that for a single charge E was proportional to 1 by r square. So this was the relation. But for a dipole, this is not a single charge but two charges separated by a small distance. So for this dipole, E is proportional to 1 by r cube. Today we are going to see that how to derive this equation, that why E is proportional to 1 by r cube for a dipole. So let us go into this. So now the field of an electric dipole, the electric field of this pair of charges can be calculated in two ways. First, for point charges on the points on the axis. So this is the first condition, and there is another condition for points on the equatorial plane. There are two conditions, so we will calculate the electric field in both the cases. First, let us understand what are the cases. So in the first case, this is the dipole, positive charge, negative charge. So these are separated by a distance 2a, and the direction of dipole P is from negative to positive. Now we have another point P, and this P is situated on the line joining these two. If we extend this line, so this P falls on this line itself. This is nowhere else but on this line itself. So this is first condition. In this condition, we have to calculate the electric field. Now the second condition is that positive charge, negative charge, and the direction of dipole from negative to positive, and the third point is somewhere here. So what is the speciality of this one? See, let us see the speciality of this second case. So there is a midpoint, and a plane is going through this midpoint, and this point is situated on this plane. This point is situated on this plane, and we have to calculate the electric field on this point. So for points on equatorial plane, so this is equatorial plane, equatorial because this is going through the center, and it equally divides the distance between these two charges, positive and negative q. Hence this is equatorial plane, and the point is situated on this plane. So let us start with these cases. Let us first go for the first case. So now see, let P point be at distance r from the center of dipole on the side of charge q. Okay, so there is a point P. This is positive charge, this is negative charge, this is point P, and this is r distance away from the center. This is center, this is r distance away from the center, and from which side? From positive q side, on positive q side. So now electric field due to negative charge is simply 1 by 4 pi epsilon naught, that much you know, and there must be a negative sign because of the charge is q. Now distance, how much distance would this be? This distance is r. So this is a, and this is also a. So r plus a. So total distance is r plus a. So 1 by 4 pi epsilon naught, charge q, and distance square, and this unit vector in that direction. This unit vector in that direction, this is P, which is also called the direction of the dipole. So this is for negative charge. This is for negative charge. Similarly, for positive charge, if we see for positive charge, so for positive charge, this distance is r, this is a. So this distance is r minus a. This is r minus a. Same, this time positive, hence negative is not there. 1 by 4 pi epsilon naught, charge is positive, and distance is r minus a, and the direction is p. Same, the direction of the dipole. So this is for positive and negative charge. Now let us calculate the total electric field. For calculating total electric field, we must add these two. So q upon 4 pi epsilon naught is common. 1 by r minus a square, r plus a square, and that direction is also same. So this comes like this, and when you solve this equation, so please solve this. This is a simple square, r minus a square, r plus a square, and try to solve this. So you will get this form, q upon 4 pi epsilon, which is common, and there comes a factor 4a r, and below you will get this square of this. You take one is negative, another one is positive, so you apply the formula a plus b, a minus b, a plus b, a minus b, and then you get this r square minus a to the power whole square. Now let us say where r is much larger than a, that means a can be neglected. So 4qa, and in the denominator r to power 4, which cancel out, and this formula comes in that case.